All right, folks, our 107th installment. We're just going to do a couple of real quick and easy problems involving scale factors for 3D models before we get into the volumes, etc., the more difficult stuff with it, okay? So still in Section 8.5, and now on our 107th installment. All righty, so we're going to talk about scale factors, and more scale factors. Let's get down to business with this now, shall we? So the first thing we want to do here is it says an F-18 fighter jet is 17 meters long. What scale factor was used in creating the model shown? So here we have a model of an F-18 that's 34 centimeters long. So what's our scale factor? All right, let's figure that out. So we know that scale factor is just the length of the image over the length of the actual. Okay, so in this case, our image is 34 centimeters. And the other one is given in meters, so let's go meters to meters. It might be easier. So 34 centimeters is 0.34 meters divided by 17 meters. So we have 17 meters there. And let's see. Oh, those numbers are going to divide nicely, aren't they? If I take 0.34 and I divide by 17, I get 0.02. All right. Which I think 0.02 is the same as 2 over 100. It's 2/100ths, which is the same as 1/50th. So this is a 1/50th scale model. Aha, there's our answer. Oh, and see how they tried to trick us with the 100, or 2 over 100, 1/200th, all that stuff, and they tried to get you thinking backwards. One way to remember this, if you're getting a multiple choice question and you're having trouble deciding, okay, I know that 50 is the right number, but is it 50 or is it 1/50th? Well, if the image is bigger than the model, if the image, which is the model, is bigger than the original actual thing, then you've got a number that's bigger than 1. And if it's shrunk down, the model is smaller than the original, then it's going to be a number that's smaller than 1. Okay? So in this case, we're not going to take one that's bigger. That's no good for us. We want one that's smaller because we're shrinking down. If you're going to go 50 times as big as an F-18, you're going to need a big room to put that in. Okay. An actual plant cell measures about 0.1 millimeters by 0.08 millimeters. What is the length of the scale model of the plant cell shown? Okay. So what is the length? So I guess we have the width of it, and we want to know what its length is. So basically, we want to figure out this. Its length along here. Okay, so for an actual plant cell, the length would be 0.1 millimeters, and the width would be 0.08 millimeters. So let's convert things here to consistent units. So 0.1 millimeters, there's 10 millimeters in a centimeter, so that'd be 0.01 millimeters. Oh, sorry, centimeters, excuse me. And 0.08 millimeters would be 0.008 centimeters. Okay, so those are our length and width. There's a couple of different ways we can do this. I'm going to do it without scale factors first, using just ratio and proportion. So these are just similar objects we're talking about. So the longer part has to correspond on each one of them. So 0.01 centimeters has to correspond to the length that we end up with, and 0.008 centimeters has to correspond to the width that we end up with, 20. So then you can just cross multiply here, and you have 0.008 L, and 20 times 0.01 is 0.2. So then the length of the scale model should be 0.2 times, divided by 0.008. So let's see what we get when we do that. 0.2 divided by 0.008, and I'm getting 25 centimeters. And that sounds reasonable if the width is 20. So we get 25 centimeters for the length. Okay? So just a ratio and proportion is one way to do that. There's lots of ways. You could figure out a scale factor, do it that way, but anything that works for you, as long as you get the correct answer, should be all right. So the length of the scale model is 25 centimeters. So all the same stuff we went through before. No, nothing new under the sun for this stuff. All right, so we'll see you in the next one, and we'll talk about scaling surface areas and volumes. Fun.